heat transfers. The transfers of heat include conduction, convection, and radiation. Importance. All forms of heat transfers are important for daily living. They are necessary to heat, to cool or warm up the body, generally just keeping warm. Importance continued. Heat transfers are also used for manufacturing many goods, managing or treating pain, and simple acts such as bathing. Differences. The main differences are that conduction uses direct contact to transfer heat, while convection uses motion of matter to transfer heat, and radiation uses electromagnetic waves to transfer heat. The differences include that radiation does not require a medium for heat to flow through as conduction and convection do. Radiation also instantly transfers heat, whereas conduction and convection take more time. Thirdly, radiation follows the laws of reflection and refraction, while conduction and convection do not. The general formula for heat transfer is Q equals mc delta T, where Q represents the supplied heat to the system or the rate of heat transfer, and equals the mass M multiplied by C, which is the specific heat capacity, and that is given by the amount of heat necessary to raise the temperature of 1 unit of mass by 1 degree Celsius. And that is multiplied by delta T, where delta is equal to the change and T is the temperature, so it's the change in temperature. Formula for conduction heat transfer specifically is Q divided by T equals Ka parentheses the T for hot minus the T for cold, all divided by D, where Q again is the supplied heat to the system or the rate of heat transfer, divided by time, little t, usually given to us in seconds, which equals K, the thermal conductivity multiplied by A, which is the surface area of the objects in contact with each other, multiplied by T hot and T cold, which are temperature for the hot and cold object respectively. And the cold's temperature is subtracted from the hot's temperature, all divided by the D, or thickness of material of which the heat is transferred through. The formula for convection, Q equals Hc times A times T hot minus T cold, where Q, as already defined, is the supplied heat to the system or transfer rate of heat, which is equivalent to Hc, and that is the heat transfer coefficient, which is depicted in watts per meters squared Kelvin, or watts per meters squared Celsius, and can generally be found by Q divided by delta T, where the heat transfer coefficient, Hc, is equal to the amount of heat transport, or the heat flux Q, divided by the change in temperature between the fluid or the gaseous area and the solid surface surrounding it, multiplied by A, the surface area, and again T hot or T cold, and multiplied by T hot minus T cold, or again the temperature of the cold portion of the liquid or gas subtracted from the temperature of the hot portion. The equation for radiation is sigma times epsilon times A times parentheses T to the fourth power minus T to the fourth power. Sigma in this equation is equivalent to Boltzmann's constant, which stands for 1.38064852 times 10 to the negative 23rd power joules Kelvin. The epsilon stands for the emissivity, or the ratio of the surface's ability to emit radiation energy over the ability of a perfect black body of the same area and same temperature, which is between the values of 0 and 1, where 1 is the perfect absorber and 0 is the perfect reflector. A, again, is given to the surface area, and t to the fourth power minus t to the fourth power. The first T stands for the temperature of the object emitting or absorbing the radiation, and it is the temperature of the environment subtracted from it. Conduction is applied in daily life, like an ice pack used for cooling parts of the body that are necessary, especially in swelling. When cooking or frying anything, blanching vegetables, which is to put them in ice cold water after cooking them to preserve their color or to eat. Something as simple as putting your feet on a cold floor, there's a heat transfer present, or when you touch something hot and it burns you. Convection is applied during situations such as air currents, where heat is constantly rising and cold is constantly towards the floor. When boiling water and the heat rises and the cold water sinks, the same principle is used for toaster ovens when they cook food, and the same process happens within a greenhouse where the air circulates to keep the heat high. Radiation happens when we feel sunlight, when you put your hand above the burner of a stove, using fire to keep warm, the heat radiates, and when cooking in a microwave, the waves radiate the food. And these are my references.